Hi everyone, welcome to the Ask Dr. Lin show, where I answer questions that hit Bakerpedia.com every day. I am Dr. Lin from Bakerpedia, the internet's largest place for technical baking information, and the only place you should go first when you need all your technical questions answered on the go. What I do on this show is to answer the questions that are most important to commercial bakers. Yes, you know, when your line is at 100 cuts a minute and you're not meeting specs on all 3 lines, who has the time to do an hour-long research on the internet? Well, this is what this show is for. Place any comments on to the topics that you're researching on Bakerpedia, and if you're lucky, I will answer them on this show. All right, I'm going to focus today's show on fermentation. Today's show is sponsored by Diosna. With their wheat plant compact line, you can produce consistent quality sourdough or preferments with gentle agitation and total control over the entire process. Learn more at diosna.com today. Today's show is about dough fermentation. Why, what, how. Fermentation in baking is a process by which yeasted dough rises, developing volume and flavor. It occurs when yeast or bacteria, like the ones in sourdough, converts the sugars like sucrose, fructose, glucose, and maltose present in the flour into carbon dioxide and ethyl alcohol. Together with a well-developed dough, carbon dioxide is trapped within the gluten network in the dough, which causes the dough to rise. Fermentation produces the leavening action, which results in the light and airy crumb in bread products. Commercial dough fermentation may include bulk fermentation or preferments, intermediate proofing, final proofing, and oven spring. Each stage, except for preferments, is a time where dough is allowed to sit, ranging from 15 minutes to 5 hours. Go to our fermentation page to find out more about this. Yeast is a single-cell microorganism, part of the fungus kingdom. It promotes alcoholic fermentation by feeding on sugars, making it an excellent leavener in baking. Yeast has 3 main roles in the fermentation process. Yeast produces gas in the form of carbon dioxide. This caused by the yeast feeding on the fermentable sugars in the dough. The carbon dioxide creates gaseous expansion in the dough within the protein matrix, allowing it to increase in volume. Dough maturation occurs by the chemical reaction of the yeast produce alcohols and acids in the protein of the flour, and by the physical stretching of the protein by carbon dioxide gas. This results in the light, airy physical structure associated with yeast leaven products. Lastly, it gives the characteristic flavor in bread and other yeast leaven products. Activated by moisture and carbohydrates, yeast is most active at 95 to 104 degrees Fahrenheit or 35 to 40 degrees Celsius. And it is inactivated at 140 degrees Fahrenheit, which is 60 degrees Celsius. Bulk fermentation is what we call the sponge stage, where the flour, water, and yeasts are mixed together to sit for a while. Bulk fermentation is very beneficial to water absorption and gluten hydration and the development of flavors. That is why sponge and dough systems are so much more easy to process and have a deeper flavor to it. In the United States, preferments are what we call flour and liquid brioches. This method takes a little of the flour, sugars, and all the yeast to do a little fermentation work to get a bit of the flavors and to get the system to start fermenting first before a no-time dough is mixed. Bakers have asked me if this system is beneficial. I honestly don't think it is really beneficial. I just think it is a midpoint between making an expensive CapEx investment on equipment for a sponge and dough system and making a no-time dough faster to process and ferment. It is in the middle of these 2 systems. That's it. So when a baker decides on which system to use, usually the decision is based on the pocketbook. Personally, I dislike no-time doughs because it doesn't provide the benefits of sponge and doughs, which are higher hydration, faster mix times, less wear and tear on the mixer, less stress doughs, and less usage of dough conditioners. Okay, back to fermentation. The third kind of ferment is intermediate proofing. Intermediate proofing is the time gap just after mixing and before sheeting. This is the beginning of the journey for the yeast, so it is about the most active time for the yeast. The final dough mixing temperature is so important for this period. Recommended final dough temperatures are about 80 degrees Fahrenheit or 27 degrees Celsius. If you get hotter than this, not only will you have molded holes because there is so much active fermentation happening, but also you'll get a more stressed dough that cannot be sheeted and molded properly. Intermediate proofing temperatures must be controlled carefully for the look and internal structure of the product. I would like to say that the final proof is like the middle child, with the oven and baking being the first child. It's just that it doesn't get as much attention as it needs to. The final proof is the time where the dough gets to totally relax and flow and rise up. Time, temperature, and humidity are very important during this time. Many bakers seem to ignore this, and it can bring many problems to the final product. Things like wrinkling of the skin, Jimmy cutters, crow's feet, and keyholes. So proper optimum proof must be performed at the proofer. Temperatures must be around 95 degrees Fahrenheit or 25 degrees Celsius. Relative humidity should be around 90%. And proofing time should be about 60 minutes. Now, I know none of you follow this because you're only worried about your first child, which is the oven, which is also the bottleneck in most bakeries. But that's this other whole discussion altogether for some other time. So please stick to a basic principle of final proof and you'll be surprised with the quality and product. Let's talk about the last fermentation journey of the dough, the oven spring. A little known fact is that your bread product can still be fermenting up to 50% of the baking time. So if it's a 20-minute baking time, 10 minutes of that time, your bread is still fermenting. Yeah, well, because why? Yeast gets killed at about 140 degrees Fahrenheit. The internal temperature of the bread just doesn't get to that temp till almost 50% of your bake time. Want to learn more about this? Go to our thermal profiling page and you get to read more about oven spring. Let me be really clear. Oven spring is the worst way to get your product to the spec height. Do not use oven spring. Always, always, always depend on the final proof to get you to your final height. Why? Because what goes up in the oven spring always comes down in cooling. In most cases, if you depend on oven spring for your final height, you would likely find issues with collapsing and keyholing of your product. Whereas, if you depend on the proofer to get you to your desired height, you will not be expecting collapse and keyholes to be an issue. So let's keep oven spring short and sweet and use the thermal profiling method, please, to control oven spring. Now that we've covered the basics of fermentation, let's look back at the yeast. In commercial baking, 3 types of yeast are cream yeast, compressed yeast, and dry yeast. In cream yeast, yeast cells are suspended in liquid. This kind is used most frequently in industrial high-speed bakeries because they fit many tank and dispensing solutions. They are about 15 to 20% in total solids. For compressed yeast, this is cream yeast with most of the liquid taken out. Also known as cake yeast, it is about 30 to 34% total solids. For dry yeast, it is the most common yeast to non-commercial bakers and bakers who are scaling up. It needs to be rehydrated before use and reacts slower than compressed yeast. It has the highest total solids at about 99%. If you're thinking about converting from one form to another, go to our yeast spec page and check out the total solids table on there. Use the total solids for your calculation to convert from one form of yeast to another. That would be a great place to start. Rapid rise is also commonly known as instant dry yeast. These contains more live cells than active dry yeast. While active dry yeast needs rehydrating, rapid rise or instant dry yeast don't. They go kapow when moisture touches them. So rapid rise is kind of on steroids because it produces more carbon dioxide and it results in a faster proofing. By the way, it's also the most expensive form of yeast. Remember that time and temperature are the main controls for fermenting and proofing. The lower the temperature, the longer the time, and vice versa. I'm sorry, I do not have the perfect answer for you on this question, but it really depends on your dough size, your spec height, and the ability to proof for a certain amount of time. And this is usually dictated by the oven bottleneck. For starters, not knowing your dough weight, I would suggest to start at 90 degrees Fahrenheit or 32 degrees Celsius and 90% relative humidity. Proof to your desired height, that is, if your final baked height is 12 cm, proof it to 12 cm. Because remember, whatever height you get in the oven should come off after cooling. And if your height doesn't come off after cooling, that means you use too much yeast and gluten. So again, use the 90-90 rule. 90 degrees Fahrenheit at 90% relative humidity till you meet your height. This is a very common question, believe it or not. Go to our page for comparison of dough systems and see how we did the comparison. We did a thorough analysis and placed the results side by side to each other so that you can have a bird's eye view of the systems. Personally, if you have an interest in a clean system with lesser dough conditioners and a richer aroma, I would suggest looking into a sponge and dough system because really, fermentation and hydration provides a more relaxed dough that needs less conditioners. Also, I know sponge and dough is going to be a little more expensive, but the ROI or return on investment on such a system with higher absorption and lower mix times would be quick if you think about it. If you need more information about this, you can buy our ebook on this topic. We will also be talking about the individual dough systems in our next few videos. That's all for today's session. Thank you for joining me today on Ask Dr. Lin. Remember, Bakerpedia can't be free without our sponsors. This session is sponsored by Diasna, the dough experts. Check out their continuous pre-dough production system that is process controlled and optimized for a consistent pre-dough quality. So, if you want to make a really good pre-ferment, go to diasna.com today. Alright, before I go, please like and subscribe to this channel. See you next time!